All right. I want to talk a little bit about this problem that I didn't explain very well in class. So just to review, we had the bike wheel, and it was propped up, and we had a string wrapped around it, and we were hanging different things from it. First, just the force sensor, and then we kept increasing the mass. So basically, we measured we measured the time it went to the ground, and then we calculated the linear acceleration, and then we got the angular acceleration. And then we made a graph, right, of angular acceleration as a result of changing the torque. Right, so we just took the tension, right? What is torque? Torque is simply tension multiplied by the radius arm. That's all it was. What I want to discuss in this video is what is the meaning of this point right here? Why doesn't it cross through 0, 0? And it has to do with the friction of the wheel on the axle. Like there's a little bit of internal resistance. So maybe I should have sprayed some WD-40 on it or something like that. So if you look at these values right here, this is X and this is Y. And 0.08, it's a small number, but this is almost 0.1, so I'm almost at 0.1, which is this would be 0.2, 0.3, 0.4, and 0.5. So we're almost at 0.1, but not quite. But what is the meaning of that number in terms of this video, in terms of this situation? So I just want to slow down and show you what's going on. So let's say we take our equation, net torque equals I times alpha. Moment of inertia times angular acceleration. Well, in this situation, we basically said there's only one torque, right? This force T multiplied by R. But there's actually some resistance due to friction. So call this internal torque, maybe due to friction F, right? And notice it's acting the opposite way. Just that's what friction does, right? It acts opposite your direction of motion. So the wheel is spinning in this direction, but the friction would act in the other direction. If we were to correctly write the equation, we would have T times R, the torque created by the tension force, minus the torque created by friction on the axle. Those are the two torques that are acting, one positive, one negative. Right, so this one's going this way, call that's actually the negative direction, and the other one is trying to make it spin this way. Don't worry about positive and negatives, just understand that they're acting opposite each other, and then it would be I times alpha. And that's it. So now I'm going to just rearrange the equation so that it matches the way I've graphed it. Okay, so I've got alpha equal. Okay, well, I'll show my work. Let's show my work. Divide each side of the equation by I, right? And then the i's cancel out. Then I'm going to flip it, so we say alpha equals TR minus that internal friction due to torque divided by I. Okay, now mathematically, instead of dividing by I, I'm going to write 1 over I, which is the same thing as dividing by I, multiplied by, now I need to keep this numerator together, so I write TR minus torque F. Okay. Now this can seem a little confusing at this point. Let's put it into basic. Y equals M, so notice our slope is 1 over I, so we can use the slope to solve for I, and this portion right here is not just X. The TR is what we graphed on the X-axis. That was our torque. We didn't even factor friction. So minus, I'm going to call this X naught. Right? What I want to show you is this value, X naught, is how much the graph shifts to the right, and that is the value of the internal torque. Right? So if I go, let's just go to Desmos and write a simple equation, and we'll start off by writing Y equals, let's say 2 times X, and then we'll change it to Y equals 2 times X minus 10. And I want to show the importance of this number right here on the graph. So what that minus 10 does. I know some of you already know it creates a shift to the right, but I want to show it to everybody. So let's go to Desmos, and we will we'll turn off this graph for a second, and we'll just make a new equation. Y equals 2x. Okay, and I'll zoom out, and I'll stretch it. Okay, so that's y equals 2x. Now, notice the intercept is 0, 0, right? But now I'm going to shift it to the right by modifying the equation. I'm going to make it x minus 10. And now you can see the graph crosses the x-axis at 10. So that value, right, that value 10 is from the minus 10 in the equation. So that's the meaning of that. The mathematical meaning is that it's that number in parentheses. So in our situation, right, if you notice, this minus TF part of the expression shows up in parentheses. That is the horizontal shift. So if we get that horizontal shift from the graph, that is the amount of internal torque. So the meaning of this number right here, that is TF, so measured in newtons. So the internal torque of the wheel, like the axle acting against the wheel, is equal to 0.082, let's say, Newton meters. That's how you measure torque. So that's just the meaning of that number.